Hello, today we are doing 5.3 notes on solving trig equations day 2. So we're going to have some mixed together when we would do an equation when we list our angles. And remember we talked about last time if it says all solutions and doesn't give you a restriction, then you need to write an equation to represent all angles that are a solution no matter the rotation, so all those coterminal angles. If you are using a plus or minus sign, be really careful, because if you drop that plus or minus sign, you're going to definitely lose lots of solutions. And one last reminder, never divide by a trig function. You will always lose solutions and you'll never be able to get them back. So we're going to solve each of the following equations, 1 through 6, over the given interval, if it indicates one. Do not give decimal answers if the equation has an exact one. If it has an exact one and you give us a decimal answer, then you would not get credit for that solution. So you want to be real careful with that. So the first one is, you'll see the trig function here, and it says from hard bracket 0 to 2 pi. That means this is a restriction. You can include 0, but you cannot include 2 pi, and you would be listing out all of the angles that solve this trig equation within that given restriction. So number 2 says find all solutions. So you're going to be writing an equation. 3 and 4 have restrictions, but notice this restriction is 0 to pi, where this one is 0 to 2 pi. And then 5 and 6, actually you're going to need a calculator, so hopefully you have one handy to be able to use on those problems, because sometimes you have problems that have only exact answers. Sometimes you have problems that have only decimal answers. Sometimes you have problems that will have both within the same equation. So we're going to work through these 6 equations today and make sure you're still on track and feeling comfortable with the solving we've done so far. So a couple of reminders that, you know, if it gives a restriction, make sure you're giving your answer within that. And then if you drop that plus or minus, you could be losing several solutions. Okay, so the first thing we're going to talk through is this one. And here is the problem. Here is the restriction. So since it gives a restriction, then our answers are going to be a list. So what I would expect to see is first, don't just jump right in and start plugging in trig identities. If you do, I'm going to count it wrong, because that tells me you don't know how to factor. Okay, we don't want fractions when we're trying to factor and get answers. So this looks like a trinomial. Everything is in the same trig function. So this factors to 2 sine x plus 1 and sine x minus 1. Remember, if you need to think about what that means off somewhere, not in your work, you could think 2x squared minus x minus 1, figure out how to factor that, and then convert it back into your signs. So here's one factor, here's another factor, it's set equal to 0. Now that you have this line written down on your paper as you would in any problem that you work, you're going to set each factor to 0 using that 0 product property that says if this is 0 or this is 0 or they both are 0, then you get an answer of 0. You learned that back in Algebra 1. So now I'm going to isolate my trig function like we talked about last class period, so I get sine by itself. So I move that 1 over, I divide both sides by 2, and now I have my isolated trig function, which is equal to -1/2. So once we have the factor down to the trig function isolated, then we go to our graph, and we know that sine can be negative in quadrant 3 and quadrant 4. And hopefully you know that that's 7 pi over 6 and 11 pi over 6. If you don't, then you could lay opposite over hypotenuse in, because that's what sine is. And then we know the angle that's opposite 1 is 30 degrees, and that means it's a pi over 6 angle. So then I would figure out what's the pi over 6 angle here, which is 7 pi over 6. And what's the pi over 6 angle in the 4th quadrant, which is 11 pi over 6. So that takes care of the work for this factor. So now we're over here at this factor. So I move the 1 over, and I need to know when is the sine function equal to 1. Well, there's only one time that that's going to happen on the graph, because remember you graph the points cosine sine. So that means cosine stayed put at 0, and then sine went up to 1, so it's at pi over 2. Make sure that you have these angles on your graph by the point where it's graphed. That's what the graph is supposed to look like and represent. If you don't do that, you haven't given me a good graphic representation. All right, so now The angles for my possible solutions are 7 pi over 6, 11 pi over 6, and pi over 2. And so that's what I'm going to do. Because the value right here was signed as x, I'm going to say x equals, and I'm going to list my three values out. And we list them because of the restriction. So anything here that you need to worry about, I think, is just kind of making sure you remember that you've got to get to this factoring stage so that you can split these apart. Don't forget your graphs, and then pay close attention to how your answer needs to look in the end. All right, so let's move on to 2. Okay, so 2 is a multiple angle. Remember we talked about when there is a number in here inside the cosine function or sine function or whichever function with theta. So we're going to think about that as cosine of theta to get our angles, and then we'll make our adjustment. So the first thing I would do is move the 1 over, divide both sides by 2, so I get cosine of 3x equals 1/2. So for my triangle purposes, I know cosine is positive in 1 and 4, so I draw in my triangle. And then cosine is adjacent over hypotenuse, so adjacent over hypotenuse leaves that to be root 3. So that tells me if I know cosine of theta is 1/2, that I know it's pi over 3 in the first quadrant. If I didn't, I could lay out my triangle, and I know that the angle opposite root 3 is 60 degrees, which is pi over 3. So I need the pi over 3 angle in the first quadrant and the pi over 3 angle in the fourth quadrant. So what this means is I have 3 theta equals pi over 3 and 5 pi over 3. So remember, we're finding all solutions, so our answer has to look like an equation. And the equation should be theta equals, because there's a theta right here inside of cosine. So I say 3 theta equals the first angle that I found, which is pi over 3. So then I do pi over 3, and because I want all the coterminal angles that go all the way back around and stop where pi over 3 is, I'm going to add 2n pi. And then to get my answer, I need to adjust and remove the 3 from the equation. So I multiplied everything through by 1/3. So that leaves me with theta equals 1/3 times pi over 3 is pi over 9. 1/3 times 2n pi is 2n pi over 3. And of course we have our nes because we have that n right in there. And we want to represent all numbers that are integers. So we want whole number rotations. All right. Then we do the second one down here at 5 pi over 3, and I want all the coterminal angles to 5 pi over 3, so I say 3 theta equals 5 pi over 3 plus 2n pi, because I want one full rotation to get back. Then I need to get rid of that 3 in front of theta, so I multiply everything through by 1/3. So that leaves me with theta equals 5 pi over 9 plus 2n pi over 3 nes. And so actually the solution here are these two equations. So make a note of that, and don't forget to put your qualification for those n values there at the end. All right, moving on to number 3. Number 3 is a restricted function, but remember it's just going from 0 to pi. So here's my trig equation. There's only one trig value, so I don't have to get anything together. I need to isolate tangent. So here's what I have. I moved the 3 over, I divided both sides by 3, and I kind of tend to rewrite this as 1/2 x as opposed to x over 2. So here's what I have, and so I know that tangent is negative in the second and the fourth quadrant. And I know for it to be 1 on tangent, sine and cosine would have to be the same value, which means they have to be pi over 4. So the pi over 4 angle in the second quadrant is 3 pi over 4. The pi over 4 angle in the fourth quadrant is 7 pi over 4. Now, if you remember this restriction from 0 to pi, that means the top half of the circle. So this right here is below or bigger than pi. So right from the beginning, we can rule out this as a solution because it's outside of the restricted area. So that leaves me working with this one. So I do 1/2 x equals 3 pi over 4, and then I would multiply everything through by 2 because I want to get rid of that 1/2. So now I have y equals 3 pi over 2. Well, there's a problem with that one because 3 pi over 2, remember, is down here, which is still outside of my restriction. So it can't be a solution either. And if neither one of them can be a solution, then that's when we would use the empty set, which is this symbol, because none of the possible solutions will actually work. Okay, so that was problem 3. Problem 4. So we have this here. I don't have an identity. Contrary to popular belief, 1 plus sine x is not cosine x. It is not a Pythagorean triplet because there is no power here. I have 2 different trig functions. I can isolate this one and then that's not isolated, or I could isolate this one and that's not isolated. So really the only other thing that I can do is square both sides. So when I square both sides, remember that is an algebra operation. The 2 is out here, the sign is inside. Okay? So I need to FOIL this together because I have 2 of those that are going to multiply, and I get cosine squared x plus 2 cosine x plus 1. And then I square this side and I get sine squared x. The problem is, remember, when you square both sides, you have to check for extraneous solutions because it can produce extraneous solutions. So we are going to have to check this at the end. Alright, so here's what I have now after squaring. I'm going to replace this sine function with the Pythagorean identity. That way I'm turning all of these into the same type of trig function. And then I'm going to collect my like terms and set it to 0. So I move the cosine squared x over here, so now there's 2 of them. 2 cosine x, and when I move that minus 1 over, the 1's canceled out. So here's what I have left. Alright, now we're going to factor, take out the GCF. So I pulled out 2 cosine x, leaves me with a cosine x from the first term and a 1 from the second term. Because remember, technically we're just dividing. Not that we're dividing to solve for the trig function, but that we're just dividing to simplify. Alright, so now I have 2 factors set equal to 0. So here's my first factor. Get 0 by itself, which it is. Divide both sides by 2. Leaves me with cosine x is 0, and cosine x is 0 when you're at pi over 2 and 3 pi over 2. So I draw my angles in my little graph. Then I look at the other term. I move the 1 over. So I have cosine x equals -1. There's only one place that that's going to happen on the graph, and that's over here at pi, because you would move 1 in the negative direction and then you would stay put. So we have 3 possible answers. These 3 are our possible answers. We need to check it to find out. So the first one was pi over 2. I go back to my original equation right here, and I'm looking to see which one is going to work. So I have cosine of pi over 2 is 0 plus 1 is 1, and sine of pi over 2 is 1, so that checks. Then I do 3 pi over 2. So cosine of 3 pi over 2 is 0. 1 is 1. Sine of 3 pi over 2, -1. And so you can see these sides aren't equal, so this one's not a solution. Then the last one, putting in pi, cosine pi is -1 plus 1 is 0. Sine of pi is 0. 0 equals 0. So this one checks out. So now we've seen one where we had to check, and again we had to check because it was squaring both sides. All right, moving on to number 5, 5 and 6, you're going to want to have your calculator handy. You're going to want to make sure that you are in radian mode. So mode, make sure it says radian right there. We'll change that if it doesn't. Okay, so the first thing is to do what you can do to manipulate and isolate the trig function. So here's what I'm starting with, and I move the cosine over because this is similar to the last one. There's really no other way around it. We're going to have to square both sides. So when I square this side, it's 4 sine squared x. When I square this side, it's cosine squared x. Then I move everything to the same side so that you have everything over here equal to 0. I replaced this identity with 1 minus sine squared theta. I'm sorry, x, not theta. I distributed the minus through. So now I have 4 sine squared x plus 1 sine squared x is 5 sine squared x minus 1 equals 0. So to isolate the trig function, I need to move the 1 over, divide by 5, and now I have sine to myself. So what does this mean? Plus or minus means that there's 4 solutions, and we have to use the calculator to be able to find it. So we are going to go into second sine. That gives us the -1. Remember, we're using this as a way to find the angle, not that we're using it as a restricted function. And then I'm going to do alpha y equals to make it look like my paper. And I'm going to do 1 down, second alpha 5. And so that's the angle. So a couple of things here. Whenever you're doing a calculator problem like this, where there's the possibility to put in a positive and a negative, I would highly encourage you to use the negative version of it, because if you, the positive version, excuse me, if you do the positive version, then it's always going to give you this angle in the first quadrant. And then you can use what you know about reference angles to find the others. So I'm going to just store this in X, so press the STO button, which is down here, and I'm going to tell it to put it in X, and I hit enter to execute. Okay, now we want to find that angle in all 4 quadrants. So remember, to find the angle in the second quadrant, you take pi minus X. So I'm literally going to do second pi button minus the X that I just stored. And you get 2.678. Remember, I wrote that down, so I approximated it to 3 decimal places. You don't want to do that when you're actually doing a calculation. And then to get in the third quadrant, we take pi plus X. And I get this one. And then I plug in 2 pi minus X. That's not right. Oh, like 22 pi. Excuse me. 2 pi. How about we use the right number? Minus X. And so that's where we get the 5.820. All right, so when you use the positive version, it's giving you this one, and then you use what you know about reference angles to find the rest. So now remember, we did square both sides, so we do have to check our answers. So we're plugging back to the original equation. Here you got a 1.7 something. Here you got a negative 1.7 something. And here you got a big scientific notation number that goes out to be point and a whole lot of zeros. So these two checked out. So when you are giving your solutions, those are the only 2 that you would consider as part of your solution. So remember, you're going to have your algebra work, you're going to have your graph, you're going to have any checks that you have to do, and you're going to have your final solution. All right, last one. Again, we'll use a calculator for some of this, but this is one of those examples where you have some exact answers and some approximations. So we start here, and we're restricting from 0 to 2 pi, so that tells us we're going to have a list of answers. And I'm going to move the 4 back over here. Kind of looks like a trinomial, however, these are different trig functions. So I want to make a substitution. Is there any way I can turn secant squared theta into a tangent problem? And that's if we use our Pythagorean identity, 1 plus tan squared theta. So once I make that and collect my like terms, making sure that a is positive so I can factor, then I need to factor. What are the factors of tan squared theta plus 2 tan theta minus 3? That will give you 0. So once this factors, and you can think of it as x squared plus 2x minus 3 if you need help, and this is how it factors with the zero product property. Then we take the first girl, and we find out that she is tan theta equals 1. She knows how to solve that. We know that 1 means it's a pi over 4. So this is pi over 4. This is 5 pi over 4. The second factor is negative 3. Tangent of theta equals negative 3. And we know that negative 3 isn't something that we're going to have on our unit circle. So this is where the calculator comes in. So I do tangent to the negative 1 of 3. Execute it. And you get this value right here, 1.29. Try that one more time, 1.249. Excuse me, guys. So when I do arc negative 1 of the 3, not the negative, remember the positive version, that gives me this reference angle, 1.249. Once you know that reference angle, you can use that to find the angle that's in quadrant 2 and the angle that's in quadrant 4. So remember, quadrant 2, I would take pi minus the reference angle. In quadrant 4, I would take 2 pi minus the reference angle. And so our solutions are the two exact answers for the first factors right over here, pi over 4 and 5 pi over 4. And then the two answers that we came up with at the flowers. So we checked all of these to make sure, we didn't square anything, so we don't have to check them. But we did make sure that we have those values. So when using a calculator, please remember that when you're trying to do this arc for the purpose of finding an angle, not for actually restricting it, that when you use your calculator, you do tan to the negative 1 of whatever that value is. That will give you the reference angle in quadrant 1. Okay, so you should be able to complete these 6 notes and feel pretty comfortable with it. We did some with the calculator today. We'll be looking at more in the near future. So thank you so much and have a great day.